Yes, welcome to panel regression, where we want to look at how to do panel regression analysis and doing the assumptions, testing for the assumptions that must be satisfied by panel regression models or data that you have. We have four libraries: the tidyverse, the PLM, the T-series, and the LM test libraries that you'll be using. We have return on assets as a dependent variable, liquidity ratio, cost income ratio, capital adequacy ratio as the independent variables. I have my data here that I'm going to read, and then I'm going to select the specific variables of interest. So if I check through that, there's a mistake there. That's my data that I've selected. Uh, there are five of them. There's MSI, but I'll work with ROA, CIR, CAR, and LR. Then the bank, there are different banks, and then there is a different years for those given banks. One of the key assumptions is the stationarity of the data. The data must be stationary for you to be able to use panel regression. And so what it means is I need to use the ADF test, the Augmented Dickey-Fuller test, where the HA is stationary. So I'm going to test all of them, the five of them. I can go through them one by one. ADF CIR, if P is less than 5%, it means the data is stationary. So the CIR, the cost income ratio, is stationary. The CAR was also stationary. The LR was also stationary according to the test. The ROA is also stationary. Then I could also do the test for MIS, even MSI, even though I will not be using it for analysis. So it helps me to see the five variables are all stationary. Then I test for heteroskedasticity using the Breusch-Pagan test. HA, it means that there is heteroskedasticity. I use the BP test. And if I say sec heteroskedasticity for that, it shows that the p-value is greater than 5%. And remember, the alternative hypothesis is that there is heteroskedasticity, so it means that there is none in the variables of interest. Maybe I should have done with ROA because that is the variable that I'll be testing out, and then I can check through and see, and it tells me that if I use the ROA, then it shows that there is heteroskedasticity. And then I could also check for serial correlation. The alternative is that there's serial correlation, the null is there's no serial correlation using the Durbin Watson test. And if I say sec serial, and then it shows that because we retain the null, then there is no serial correlation using the MSI. That is the other test that must be satisfied. And then you want to know, am I using a fixed effects model or the random effects model? You use a Hausaman test. And so what we do, you take your models and use a PLM. We use the LM linear models when we are not having a panel data, but since my data is panel, I'm using the PLM function. Remember, we said at the beginning that my data is sec panel. It was some secondary data, and so that is why I'm saying data is equals to sec panel. So I check, I do the PLM using the model as within and random. And then if you wish, you could see the summary there. But this is the part I'm interested in. I take the sec and the random, I do the pH test. It says that the p-value is 0.26. 6, which is more than 5%, because this is 26.84%. Therefore, what do we do? If each node is a random effect, if it's HA, it's fixed effect. So this p-value is more than 5%, so we retain the null. That shows that we should use the random effect model. That's what it would tell us in our case. So now if you do your analysis, you use the random effect model when you do the actual modeling of your data. So, and that is exactly now how I can go about getting my panel analysis. And there we go. I have the analysis there from this model, ROA, return on equity in percentages. That's what the PCT stands for. And it shows that all the CIR and CAR, their increase as a negative effect on the return on equity. Increase in liquidity seems to have a positive effect based on the estimate values, but it's only the CIR, cost income ratio, and liquidity ratios that are statistically significant. We also have the R squared value, 40.33%, and they are adjusted at 38.25%. So then one could go ahead and discuss the analysis of their work or the results that they got from their model that they have developed based on this. So these are the key tests to check if you're going to use a fixed or random effect. Then they see the issue of serial correlation, heteroskedasticity, and the stationality of the data. If the data is not stationary, then you need to make it stationary. There are things that you can do about that, but I wasn't covering that today in this video. So thank you so much for watching.